This is the second half of Lesson 7, where we're going to be going over misleading graphs. And this is really what the whole course is about. Statistics display has a lot of influence on how information is interpreted by an audience. We have to know how to display our data properly in order for it to be interpreted appropriately by our audience. So labels, scales, titles all make a huge difference when we're creating our graphs. When displays are misleading, wrong conclusions can be derived about the data. And so different ways graphs could be misleading. They might use a title that suggests something different than the data. They might leave off labels or scale. They might use a very small range of numbers to make differences look larger. Or they might use a very large range of numbers to make differences look smaller or minimize the differences. They might begin a scale at a number other than 0. And when we look at this, we're specifically looking at our y-axis, because we can always use the heartbeat break for our x-axis. We cannot do that on the y-axis. They might use a scale with uneven increments. Or they might use a 3D design to make it harder to compare different pieces of information. So there's several graphs on the page that we're going to go over. We're going to discuss how it's misleading, what they could have wanted it to be, and what we need to change it to make sure it's not misleading anymore. So the first two graphs, we're going to look at the composition of honey. This graph is misleading for a couple of different reasons. So first of all, the graph is not circular. So we're looking at this hexagon-shaped graph, which they probably chose to do because they're talking about honey and beehives. But then when we look at how things are distributed, so if we look at what might have been like the halfway point on the graph, we have this huge big slice representing 38.5% that takes up more than that. So not only is the graph not circular, the wedges are not the appropriate sizes. So if we're looking at even these really small wedges, 0.5%, 1.5%, 4.2%, those look like they take up a significantly larger portion of the graph than what their value actually suggests. So misleading because it is not a shape that we are familiar with, not one that we can reference quickly, and the wedges are not an appropriate size. In terms of making this graph misleading, they probably just thought it looked cool to make it a honeycomb shape. It touches base with the data because we're talking about honey. If it wasn't just because they thought it would look cool as a honeycomb, maybe they're trying to misrepresent the amount of sugar that's actually in honey, making it look like there's way, way, way more sugar or way less sugar if they're looking at how large they sized some of these. So some ways we could change this so it's not misleading. Really, all we have to do here is make it circular and adjust the size of the wedges. And that should put it in a format that makes it fairly easy for people to use. So if we look at the second graph, most first rounders, so we're looking at draft picks within a specific amount of time. Why is this graph misleading? Well, when we look at the numbers represented here, 47, 49, 60, 64, 69, those aren't percents. Those are the number of times they've had a first round pick. So the pie chart doesn't represent percents, and it needs to represent percents if it's going to be a pie chart. If we also look here, we've got a little bit of a 3D design going on with this blue circle. It's not a pretty distinct 3D design, but we do have significantly more blue on one side of the graph than we do on the other. So why would someone want to make this graph misleading? Maybe they just want to make it seem like one team has significantly more first-round picks. So one thing we're looking at here, if we look at these numbers represented, 69, 60, 64 are all pretty close in numbers. But the South Carolina pie wedge is significantly bigger than either of the other two numbers that are close to it. So we're definitely misrepresenting number of first-round picks. And something we can do, we can remove the 3D display or the 3D effect and convert the data to percentages. So that's two examples that we did together. Why don't you pause the video here, do the other two examples with the football power index and the unemployment rate on your own, and then start the video again when you're ready to go over it. So with the ESPN power index, we've got projected win totals for 2018. Things about this graph that are misleading. When we look at this graph, we have the values going in order from highest to lowest down the table, but specific bars are longer than others despite their values being lower than others. And that's because the bar is just based on how long the words in the bar are. So our bar length doesn't represent data. It just represents the length of that line. So in the case of South Carolina and Mississippi State, their names are longer than some of the other colleges, so of course their bars are longer. Why would someone want to make this graph misleading? It could be unintentional, or they could be trying to make Mississippi State and South Carolina look better. All right, ways we can change this so that it's not misleading. We can make the bars proportional to the data that they represent. So instead of having bars that are just as long as the actual line, we could actually draw out the Georgia line. We could draw out the Alabama line, and so on, so that these values actually are representing what we want them to. Now, as a side note, I don't know that this power index was ever intended to look like a bar graph. I think it probably was just put together as a list that people thought looked cool that represented the values of their power index. But if you consider this from a statistics standpoint, it absolutely could be read like that. So we want to try and minimize reader confusion. In this case, either fix the way that we're representing the power index or just make the bars proportional to the data they represent. So then in our last example, U.S. unemployment rate between Bill Clinton's years as president and George W. Bush's years as president. If we look at this, we have the 3D model. which makes certain bars look significantly bigger than others. Also, our y-axis doesn't start at 0. So we don't start at 0, meaning we're not actually showing the difference, and we've used a really small scale. So if we read the actual values, 5.18 versus 5.20, even if we round those, 5.21%, 5.19%, there is very little difference in those percentages, but because of the scale we've chosen on our y-axis, we're actually maximizing the difference between these two bars, not only with the 3D effect, but also with our choice of scale. So, in terms of why someone wants to make this graph misleading, we see this a lot in politics. We see this a lot in news in general. The graph makes it seem like one party has a significantly higher unemployment rate. So it makes it seem like the Democrats had a much higher unemployment rate, when in reality, if we look at these two values, they're quite similar across those years. So how can we change it so that it's not misleading? Adjust your y-axis. We want it to start at 0 and use an appropriate scale. We also want to get rid of the 3D effect. So, in order to properly represent our statistics, it's important that our data displays do that. So, this is why everything that we just went over in Unit 1 is so important. We need to make sure that when we communicate our data to people, is actually communicating what we want to in an unbiased method. And for the most part, when we talk about misleading graphs, people aren't necessarily intending to be biased. They're just not aware of the appropriate ways to represent statistics. So that is what we're going to be trying to learn all throughout this semester. So that is the end of lesson 7. This is our misleading graphs and how we can fix graphs to make sure that they are not misrepresenting our data.